I'm Max, co-founder at LimaCharlie. I think most people probably sort of vaguely know me at some point. Yeah, today what I really wanted to talk about is kind of a meta topic here. So LimaCharlie, I'm going to cover a little bit like at really high level, like, you know, what we do, kind of just set the baseline here. But what I wanted to get into is our approach and how we've been able to build certain things and the philosophy that goes behind it and what I think are kind of the advantages of doing that. So it's kind of me preaching a little bit about this type of system design, I guess. Cool. And so let's get going. All right. So this is the really high-level view of what we're going to be talking about. So I'll just talk a little bit about what LimaCharlie is. Then we'll get into the puzzle pieces. And you'll see that I will be talking a lot about kind of cloud provider thinking as well as the generic thinking. So we'll talk about a bunch of different puzzle pieces that we have in LimaCharlie. And then the interesting part is the patterns, meaning how do these things combine to create new things? And really, that is exactly the core of what I wanted to talk about. So let's go. LimaCharlie, if you've been around us, you probably heard like the SecOps Cloud Platform. I kind of put all of the different ways people think about us, or a bunch of them, just because different ways resonate differently with different people. So the SecOps Cloud Platform is what we say we do. We wanted to put a word on it. Really, you can think of it as a public utility for cybersecurity primitives. You can think of it like a cloud provider for security primitives. You can think about it like Lego blocks for cybersecurity. But the TLDR is, you know, we're kind of built like a cloud provider. We make a bunch of different Lego blocks, a bunch of different things that you can use, and then you can assemble them in different ways that become interesting. So let's get into the puzzle pieces. So there's a bit of an order here that we're looking through. So the first part is how do you actually get data in, right? This is really core part of what we do. You'll see some, you know, the previous speaker mentioned the data pipeline. This is exactly how to kind of think about it. So first puzzle piece that we have is, so there's an agent. Okay, so we have an agent puzzle piece. Sometimes people think EDR. We kind of tend to use the generic agent because it doesn't have to be an EDR, and we'll get into what that means. But, you know, hey, I've got this thing, can be deployed on native endpoints, brings telemetry in, can take action. And you see that I'm talking here in terms of generics. And really, that's the point, right? That this isn't a prescriptive way of building things, but rather it's a generic way, which means most people have to, you know, do some tweaking to kind of get it to do the thing that they want. Then the sum, the outcome is greater than the sum of its parts. So we have this agent, real-time telemetry, all that stuff. Then we have what we call adapters. This is a way of bringing in data in a generic way from other systems. And we, like, it's really, really, you know, generic in the sense that at its fundamental level, it's JSON over WebSocket. The protocol is open source. The client is open source that we made in Go. And even the collector itself, so we have this adapter, and that's also open source. Because really fundamentally what we're talking about is, hey, I want to get data from something and then pipe that into LimaCharlie. And this translates into kind of three different ways of doing things. There's the cloud to cloud, meaning, hey, LimaCharlie, take Office 365 and bring it into LC. That is candidly just us using the adapter hosted in the cloud. There's no difference. It's all the same thing. Then we've got the webhook. So you can have a webhook being defined by LimaCharlie in the cloud, and you can send stuff to it. As with all the adapters, it gets converted. It all goes into JSON, and that's really a critical piece of this generic approach. Is we have to have a very generic way of interpreting data in the cloud, and sadly, that means we don't want to be prescriptive about like, here's the one schema and everything's got to fit into that. But instead we say, look, JSON is the thing, and then there's some adaptation that needs to be done here. And so yeah, the final one's kind of the obvious one. It's like, okay, I've got this adapter, it runs on premises, connects into LimaCharlie, sends stuff. And I'm being super vague, and it's really on purpose, right? Send stuff can be firewall logs, but it can also be, I run this CLI tool and I want to send standard out, into standard in of the adapter and bring that in. It could be I'm building an application, like some software that runs on the desktop of my analysts, and I want to feed, very specific things directly from this app into LimaCharlie to go and do things. So the final one is the artifact. So the artifacts is, again, super generic. It's any kind of bulk type of files, right? So, hey, maybe you're doing an IR and you have a memory dump. Bring that in. Maybe you are doing network analysis and you've got PCAPs. It can be any bulk files that can be brought into LimaCharlie through a REST API or through the agent. And that's what we call artifact into LimaCharlie. So those three things are the bulk ways of how you can bring data in. Okay, so far, a little bit boring. Data, data in, okay, cool. So let's look at the other end of that pipeline. It's the data out. Kind of taking the sandwich approach here. So data out, again, pretty simple to understand. It really, so it boils down to sort of two different categories of puzzle pieces. We call them outputs. So outputs just means, hey, LimaCharlie, I've got this data coming in. Take this part of the data, maybe like modify it here and there, and then send it out into the world to something else. Again, I'm being super generic, is really on purpose, right? It could be, here's like a syslog endpoint, maybe it's an S3 bucket, maybe it's a Kafka topic, maybe it's like anything out there. And so that's how you're able to connect into other things. Finally, artifacts can be exported. Again, same kind of concept, right? Like we've got these artifacts coming in. Well, we're able to trigger an export of an artifact so that some other piece of the puzzle, somebody else is able to pick that up. Then, in the middle, we have the automation. That's kind of the glue that's going to complete the picture of the puzzle pieces within LimaCharlie, and then we'll get into the cool stuff. So the detection and response rules, our DNR engine, is really simple conceptually, right? It's, hey, if I see X, then I want to do Y. And it's very generic over JSON, so it doesn't really matter, what the thing is. It operates in real time across all the things, and the Y can be most of the systems in LimaCharlie, which means I can start to say, like, hey, if I see this thing coming in from a webhook, then I want to, trigger the export of an artifact somewhere else, or I want to do, something else. Then, this also applies to a lot of meta events within LimaCharlie. That's actually a really critical part of this, meaning everything that happens within LimaCharlie is also telemetry itself. So that means that when an artifact is ingested, well, that's an event. Even though nobody really sent us that piece of JSON, we'll emit that event, and then you can automate off of that. We also have things like secrets, like pretty standard kind of, generic piece. Within a platform, we have extension requests. That's going to be super, super critical to the next part of where we're going. But the idea is we can, in a generic way, issue a request to what we call an extension, which was mentioned a little bit during the first day here. But an extension is just a piece of code that is kind of streamlined to interact within the life cycle of everything in LimaCharlie. So we can issue those requests in a generic way. And then finally, another really critical piece is the payloads. So the payloads in LimaCharlie is us saying, hey, maybe you're running a native agent. I have this thing that I want to get executed on this native agent. And then I want to maybe take the data that's generated by that. I want to be able to just control it in a generic way. Finally, so extensions, to dig in a little bit more into the extensions. They take care of multi-tenancy, all of that boring stuff. They're part of the lifecycle management, meaning this idea that, like, hey, a tenant might subscribe to an extension. This is all just keeping the lights on kind of things. They define a schema that users can use both from the UI perspective in a generic way, but also that defines the types of requests that you can make to an extension. So that part is well defined, and everything can interact with extensions. All right, now we're getting into the interesting thing. I'll take a sort of a conceptual pause here and actually talk about a cloud provider. So if you're thinking about, let's say, AWS, or for me, it's GCP is my world, and you're thinking about, let's say, in GCP, it's GKE, so Managed Kubernetes Engine. I think it's like EKS or something, I want to say, in AWS. I might be wrong. It's worth kind of taking a pause for a second and thinking, what does that mean within that realm? How do the cloud providers think about how they structure that product, right? That thing that they're doing. And the way that they do that, or the way they're not doing it, right, is this managed Kubernetes. What they're not doing is they're not saying, like, hey, managed Kubernetes has its own very completely unique type of virtual machine. And we build those types of virtual machines just to be nodes in that that product. And then we built like a unique bespoke firewall product to go around those nodes. And we built bespoke stuff for every one of those. That is not how they do it. How they do it is they just say, well, look, Google Cloud Platform has virtual machines already. They have firewalls, they have network routing, they have logging. Well, if you kind of just put all of those things together, and then you write, this little bit of, I'm understating it a little bit, but this glue code in the middle, now I have managed Kubernetes. So that's exactly what I mean when we're talking about the outcome being greater than the sum of its parts. That is the goal of LimaCharlie by building these puzzle pieces and getting that outcome. So let's get into some patterns. So the basic one, I don't even, yeah, I do have, sweet. So this is really the most common use case, and I'm gonna mention it because it's very good, very powerful, but I think it's also exactly where everybody goes. If you've been part of a SOC, that's kind of where the mind goes. So the idea is, well, I have these agents, and it's native agents deployed everywhere. Okay, cool, that's kind of like an EDR. They can bring telemetry in. Okay, I'm gonna go, I'm gonna do that. I'm gonna take this telemetry in. I have this automation engine. That's great. So I can say, well, if evil.exe runs, then I'm gonna create an alert. Again, that works perfectly well with those puzzle pieces. Then you might say, you know what, I also have a SIM and I have a ticketing solution. So, well, I'm gonna use the output solution to go and say, the detections I've generated and this and that part of the data, I'm gonna go and send to that SIM or whatever external system that you may have. It's really a classic. That vision of the world, I don't think has anything new here. It's sort of, if you're working in SOC land, that is exactly how you're thinking. But that's not just it. So let's look at a very different vision of the world. So reliable tasking. I'm starting at a point that's a little bit, it's probably on the more boring sides of the patterns that we've got that we can talk about. The justification, like what we want out of reliable tasking is pretty simple. So in LimaCharlie, if you've got an agent and you want to send a command to an agent, by fundamentally, all of this is real time. So if that laptop is offline, you're going to try to send a task, and it's not going to work because that agent's offline. And we're just going to tell you that thing's not connected. Sorry. So reliable tasking is us saying like, hey, it would be kind of nice to be able to say, you know what, I want you to go and get, the process list from that box, but I understand that box might be offline. So instead, wait up to, I don't know, a day for you to try to reach that endpoint. And if that endpoint comes online, then you can send that task, right? So it's really in the name, it's the reliable tasking. So this is really a cornerstone of a lot of the capabilities in LimaCharlie, because it turns out that sending things in a reliable way is really important for a lot of things. But for us, this is an extension. So we're not looking at this as, hey, we need to build this into the product and this complex feature set and like all this complexity. We're looking at this as another piece of the puzzle. So we built an extension. This extension lives somewhere in Google Cloud. Extensions can live anywhere. It's it connects over webhooks, so that's how extensions work. You've got LimaCharlie sending a webhook to the extension with some configuration data, the information about the request, all that stuff, and it gets a response. So in LimaCharlie, it means that So I have this extension. First thing we said is, okay, well, if we're going to have to remember tasks, right? Maybe you told me like do a process list on this box and it's offline. Well, I'm going to need a database. We look for simple solutions, so we're using data store, I think, in Google Cloud. Something really simple. So we've got a database. That's good. Now we need to know when we should send that command to that agent that just woke up. Maybe, like it was offline or it was on a plane ride, so they just woke up at the airport. How are we going to go and trigger this? Well, we have this DNR rule engine, right? Like we have this engine that says like, hey, if X happens, then do Y. Okay, that fits pretty well here. I can show you the little bits of code. I didn't want to go too heavy in code, but I'm partial to it. But the idea is, well, we can now say, you know what? When an agent has a connected event, then what I want to do as an action is I want to tell reliable tasking about this. So our reliable tasking in its schema has said, you know what? I have a signal online type of request that you can make to me. And all it's doing is you're just telling me this thing might be online. So when we install the reliable tasking extension, what we do is we install a DNR rule that says whenever a sensor connects, you let us know. When I say us, I mean the extension. So that extension receives the notification when something comes online. And then, it's pretty simple logic. When we get that notification, we can just go and say, okay, well, I have, let's look in the database. I have these 10 tasks that have been waiting for that sensor. I'm going to go and I'm going to try to send them to the sensor. It's pretty straightforward, but also a really compact nugget of value, right? What's the value? What's the advantage of doing this here? Doing this as an extension means that we're completely decoupled from the rest of the infrastructure. It means that this exposes not some kind of API within the backend that maybe some components from LimaCharlie only are able to understand, but rather this is a reusable bit of code, bit of value that we can expose to the rest of the community, rest of anybody using LimaCharlie to use in all kinds of ways we have no idea about. Okay, so that's a simple example. Let's get into more interesting examples. The Cloud CLI, it's kind of a very different kind of example. It's more recent, so I think we released this a couple months ago. And it was this idea that we said, hey, a bunch of people are responding more and more in the SaaS world, as we had a talk yesterday about. And very often, people want to be able to do something, let's say, against a cloud provider or Okta or whatever SaaS platform. Very simple example for me that always comes to mind is, hey, we detected some piece of malware on an EC2 instance. I would like to be able to go and shut it down. Simple enough. How are we going to do that? Well, we could have said, you know what, we're going to engineer some custom code in the back end that is going to know about the API of all of these things. But then we had this aha moment of all of these cloud providers, most of the SaaS providers already want people to interact with their systems in a structured way. And that's called the CLI, the command line interface, right? So in AWS, you're going to have an AWS CLI, and it can interact with pretty much everything. So we had that realization that what we could do is we could create this extension. So it's a simple extension. It uses secrets. So in this case, we said, you know what, we don't want people to put AWS secrets into, where are we going to store it? Extensions are kind of fundamentally stateless. You don't need any storage unless you really need it for what it's doing. So we said, we don't want to deal with this. Well, LimaCharlie has secrets. Great. Define a secret in LimaCharlie. The schema for this just says, like, hey, when you send a request for a CLI, you include whatever secret you want into that, and that's what we'll use. So then what we were able to do is say that this extension, all it had to do at this point was it's a Docker container. We install all of the CLIs. And when we get a request from a user, I say user, but it's really not like a human person necessarily. It's really just, it could be automated, could be through API, all the different ways. We're going to take that CLI, and we're going to try to, make it happen using those credentials. I'm kind of skipping a little bit over a lot of like authentication headaches that come along with that. Happy to have that discussion, but it's kind of a messy one. So, okay, that's cool. Now anybody can now send a thing to say AWS or Okta or Ocean, DigitalOcean, do this thing. That's good, but that's just one way, right? It's a one-way ticket of making something happen. It'd be nice if there was a better way of doing feedback, having feedback into LimaCharlie. That's when we came to the next pattern that we established. And it's that last bit there at the bottom. So we have this generic way of bringing in JSON into the platform. Well, what says that an extension can't bring in its own feed of telemetry? So we said, okay, you know what? When we're going to execute that CLI, for each CLI, we're going to, depending on the CLI, make it output JSON. And then we're going to define our own JSON feed. And that extension will create its own adapter in LimaCharlie. So I think we mostly use webhooks. So the extension is going to define a new webhook only for itself, it owns the shared secret. And when it executes a command line, it's going to record this, like the fact that it did, and it's going to record the output as JSON from that command line. So now you start to connect the dots. It means, hey, maybe I have an automation rule that said, like, turn off that machine in EC2. The EC2, JSON like output from that gets emitted, gets re-ingested into LimaCharlie. And now it means that a user is able to say, okay, I'm going to create then an automation rule that says, hey, when my AWS CLI, as a response to a thing turned off a box, I'm going and send a webhook via the outputs of LimaCharlie to a Slack channel. Or it's going to go and say, I'm going to take that JSON. Maybe instead of turning off a VM, what I did is I disabled a user in Office 365, and I got all the metadata about that user. Well, I'm going to re-emit that. And now that comes in LimaCharlie, I can do additional logic, additional automation on top of this. We're not prescribing what you should do with this. That's really the beauty of this generic component. You might use it as part of a SOC. You might also use it as part of building a product for something else. So this was a big pattern for us. From this point on, we started to add this to every single extension that we were building. Feedback into LimaCharlie, because we never know what's going to be useful. All right. Here's a big one. This is a big one that we did. It's called binlib. The really high-level pitch is that binlib stores all executable ever run on a tenant. So, hey, an exe ran, a DLL ran, a sysfile ran, a .so, whatever it is, we're going to go and we want to capture that into this data set that's available to you, both capture the original file itself. So again, clearly not documents, not emails, and any of that stuff, like executables. And we're going to, we want to allow you to go and search metadata through this data set to do automation, and then maybe automate some kind of hunt using that. But fundamentally, you know, that's why I really love the previous presentation talking about data pipeline, focusing the expert, each individual expert. This is a focused expert, right? This is not a, hey, it hunts for a bad guy and then flashes this red light if you've been hacked. No, this is a, I just maintain a big list of everything that's ever run, and I allow you to search for things in it or run Yara at scale on it. Which rules? I don't care. You just tell me the rule and I'll do the scan. So this is what we wanted to build. We wanted to build this generic component so that others could then start to leverage it for building, you know, all kinds of new stuff. So what does it look like for LimaCharlie and to build this? Well, it starts with an extension. Again, you can see that the extension pattern is kind of the big one. Well, we're going to need databases, really. We opted to use BigQuery. Again, we like things that are fully managed, so we're using Google Cloud BigQuery. It allows us to build one data set, which is like a database per tenant. And that is where we're going to store all of the metadata that we extract from binaries. That container is also going to install Yara because we want to be able to do Yara scanning at scale. The extension relies on another pattern that we have done quite a few times, which is, again, like, sorry, I use GCP wording, right? But we're using Cloud Run in GCP, which is just like, here's a container, run it once or 5 million times in parallel, whatever you need to, you know, to come to the load that I send to you. And what it means is that that allowed us to go and kind of bake into this scanning of Yara at scale, because we're able to just say, hey, you want to use this Yara rule on these 5 million different executables from that tenant. We're able to just feed that back into the extension itself and let Google do the whole heavy lifting of just, you know, giving you like 1,000 different containers in parallel and just crunching through all of the Yara, all of the scanning at scale. So the next thing that it does is it needs to fetch binaries as artifacts, right? I mentioned like, hey, we have this artifact system just blobbed of data. Well, it turns out an executable like fits that bill pretty well. It's kind of a blob of, like, it's a file. So we are going to use this artifact system in order to kind of stage this acquisition of the binaries as we need to get them from a tenant's environment. And really, to accomplish that, we're going to need the DNR rules. So we're going to create some detection and response rules that will say, hey, there's a new hash that we haven't seen on this particular endpoint. So we use a code identity event in LimaCharlie. It's kind of semi-deduplicated hashes from endpoints. And this rule is just going to say, hey, you know, suppress duplicates using a feature of the DNR engine. And for those hashes, send them up to the extension. So the extension gets a shot at saying, have I ever seen this hash? No, or yes, I've seen it. Cool, nothing to be done. Or no, I've never seen it. In which case, it's able to feed back into LimaCharlie and say, hey, LimaCharlie, go collect this artifact from this endpoint. And then when that happens, we get an event from LimaCharlie through a different detection rules that says, hey, an artifact was just ingested for you. And so the extension is able to say, thank you. Please export this artifact so that I can get it in my own environment. It does that. And all of this activity is logged using adapters, right? So again, it will narrate all of that activity back into LimaCharlie so that as a user of some kind, you're able to see, yeah, this hash, you know, was never seen. And we decided to acquire it. And we did acquire it, and this is the metadata about it. At every step of that, you know, that process, you're able to customize what you want to do with it. And finally, yeah, searching and scanning from requests. So that extension gets requests to scan stuff, to search for things, and you're able to use that. So now Anybody that uses LimaCharlie in whatever way imaginable is able to leverage all of this without having to code any kind of custom bit of code. So the last two ones are very kind of IR, not specific, but like very kind of heavy lifters in IR. So we have Strelka. Strelka is an open source project by Target, not the vendor, the retailer. And so it's this thing, it's this system that is designed to do very powerful scanning characterization of binaries at scale. And for anybody that's been, that's tried to use these types of systems at scale that come from open source, there's a common thread that it's tricky. It's tricky to get right. And it sounds amazing, but then I need to get procurement on board to get the hardware done, and then to get the network team to give me, the Kubernetes cluster to run the thing, and it's a pain. So we said, well, that sounds like an extension. So this is exactly what we did. We made an extension. Built Strelka. There's a little bit more complexity. We had to go and build, a cluster, a GKE cluster, to run a lot of the Strelka binary, so it runs at scale. And then our extension is just kind of the glue between this and users, and the firewall as well, between users and the output. So that, much like Benlib, it can go and fetch the files as needed, right? So you can, or it doesn't fetch it directly from the endpoint, but rather it makes the assumption that like you fetch the file as an artifact, and then you can make a request to Strelka to say, take this thing, run it, and tell me what you know about it. And that's going to use DNR rules to go export the artifact, process it. All the data generated by Strelka happens to be JSON. Gotta love JSON. So we just re-ingest it. So now, as a user of some kind, maybe I'm a SOC, maybe I'm a product, maybe an MDR, it doesn't matter. I'm able to just, at scale, without worrying how it's being done, make these generic requests that say, like, hey, parse this file in the default set of parsing that's done by Strelka. And I don't have to go and build any of that infrastructure. The last one is also really, really popular, the Velociraptor one. So Velociraptor, for those that don't know it, it's a defer tool to do deeper forensic extraction from systems, right? LimaCharlie, we're not really like a deep encase type thing. But Velociraptor does a really good job. They're also really structured in a really friendly way to be run as a one-off onto systems. And in the open source, you kind of have to go and install the server and bring up the infrastructure and set up the certs and all that stuff that's a pain. And so we had that realization, well, that feels like an extension. So we built this extension, and what it does is when it gets a request from a user that says, like, please use this Velociraptor artifact, which is a specific type of thing, like they have their own artifact definition. What we'll do is we will go and fetch the latest, greatest version of Velociraptor automatically from GitHub, the latest release. We will stage it as a payload on LimaCharlie. What that means, right, the payloads is where you can run an exe or a shell script or whatever. So it's going to upload it, wrap it up with the request that you had for Velociraptor. Like, hey, I want you to go and get like, triage files from this and that. And then it's going to send that request to run that payload to the endpoint that you specified. Because most of the things are kind of designed to run at scale in LimaCharlie, it means you're not saying like this one box do this one thing, but instead you're saying like, hey, all of my Windows endpoints that have the suspicious tag on it, go and do that. And this uses reliable tasking because we wanted to say, hey, you want to do that Velociraptor thing, but like that guy's on a plane and you want to do it on his laptop, you don't want to wait. Reliable tasking just solves this whole thing for us. So just task it in reliable tasking, give it a week, like try for the next week to get this artifact. That happens, the artifact gets uploaded into LimaCharlie. We have a detection rule that will say, hey, we've got a new raw payload from Velociraptor. Cool. The extension will grab it. It knows how to parse it into JSON. So it'll parse that raw log into JSON, and it's going to re-ingest it into LimaCharlie. So now anybody can say, hey, I want to automate things off of the Velociraptor as, you know, like retrieved from LimaCharlie, and I want to just automate things. So, sorry, I think I went a little, like 2 minutes long. So that's, you know, my goal here was to kind of give you like a really wide breadth of ways in which we've leveraged LimaCharlie and with the logic that we built into LimaCharlie, right? Sometimes I think some people are kind of like confused a little bit as they approach LimaCharlie because they're used to, here's the button to trigger the collect artifact thing from my endpoint. And don't get me wrong, like that, the world needs that, but it's not how we're seeing the world. How we're seeing the world is in these generic blocks that people can plug together and build things that are at every step of the way just bigger than the parts. Thank you. Any questions? Sure. Oh, yeah, that was actually the part there. So many things are next. One of the big puzzle pieces that we're putting in is going to be around graph database type of concept. So this is still early in development, but the idea is that this will allow you to go and do things like inventory management. But again, don't look at it from the prism of, hey, this is, you know, this is the GUI that does the thing and that's it. We're looking at this from the, what can people build and build using graph databases if you didn't have to provision anything, you didn't have to manage load, you didn't have to manage multi-tenancy, and it plugged into every other thing. So I think pretty exciting in my book. All right, thank you very much.